All right, today we're going to start chapter 7.2, which is titled Law of Cosines, so I figured that'd be a good place to start, Law of Cosines. These are all the same rule, it's just depending on what angle you're given. So if you're given side angle side or side side side. All right, if you're given side angle side, you're pretty much bound by what angle you have as far as which one you can use it. So if you're given angle A, you'll use this one, angle B, this one, angle C, that one. If you're given side side side, my recommendation is to find the angle opposite the largest side. That's going to be the largest angle. That's the only one that could be obtuse. Law of sines, we have that whole ambiguity problem. We get the with the side-side angle situation, right? Where we maybe have two sets of answers. Law of cosines doesn't have that problem. So if there's an obtuse angle, it'll find it. If the biggest angle is not obtuse, it will tell you that. So never use law of sines to find the biggest angle. Use law of cosines at this point. So with that in mind, law of cosines simply is the Pythagorean theorem minus an extra term. And the extra term is 2 times whatever the two sides here are times cosine of the included angle. So if I'm doing this one, this top one here, just to give you an idea, we have side A opposite angle A. Okay, whatever side this is what's going to match that angle there. The other two things, the other two sides are going to be everything else. So you got B and C, b squared and c squared minus 2bc. When I say side angle side, side angle side like that, so side side angle is still a law of sine situation. You have to do it that way. But if you have side angle side where the angle is in between the two sides, you know it's a law of cosine situation. And if you do have to use law of cosines with side angle side, your first thing you're going to find is the other side. Once you know the other side, now we can go back to do law of sines to find the other angles. All right. If I was doing this problem, we can see B looks obtuse, right? So if I was doing a problem that gave me B, C, and angle A, I'd find side A first, then I'd find angle C with the law of sines, because that's acute, because this side's going to be smaller than that side. And then once I know these two angles, subtract 180 to find the obtuse angle, if it is obtuse. All right, so that's the scenario there, is that's how we're going to use the law of cosines. Again, for side, 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 just always find whichever angle is opposite the biggest side. That'll be the biggest angle. That's the only one that could possibly be obtuse. So let's try it out. In triangle ABC, B is equal to 110 degrees. A is 10.0 centimeters and C is 15.0 centimeters. Find B. All right, so side B, that's all I want us to do is find side B. I'm going to go ahead and find angles A and C also, just in case you get asked that type of question in homework, you can see how to do that. So I can see that I've got side angle side information given to me. Once I see side angle side, the correct decision to make here is use the law of cosines. If I apply the law of cosines, I've got B opposite angle B. So I'm going to use the B squared equals A squared plus C squared minus 2AC cosine of B. The only thing I don't know is B. Everything else over here is known. So just at this point, it's just a matter of substitution. A is 10, so 10 squared is 100. C is 15, C squared is 225, minus 2 times 10 times 15 cosine of 110. So that's just, all we have to do really is just apply the formula, put the numbers in, and then our calculator can calculate. So if I type in 100 plus 225 minus 2 times 10 times 15 cosine of 10 equals, comes out to 427.6060. So if B squared is equal to that, then B is going to be the square root of that. So square root of 427.6060 comes out to 20.68. And in fact, let's go 6786 here, because I want to find more stuff. For my final answer for B, if I want to go 2 decimal places, that's fine. But I have to use B to find angles A and C, so I'm going to keep those at 4 decimal places, just to work it out. So at this point, if I identify what I know on this triangle now, this side is now 20.6786 centimeters. And if I want to find angle A or angle C, then I just have to use the law of sines. So if I did that, I'm going to get 20.6786 over the sine of 110 degrees should equal, let's go with 10 over the sine of A. All right, sine of 110 is 0.9397. So if I cross multiply and divide by that, I'm going to get sine of A is going to equal, let's try it out, 10 times 0.9397 divided by 20.6786 comes out to 0.4544. So A is going to be the inverse sine of that. I'll shut my calculator down. Here we go. So if I do second sine of 0.4544, we get 27.02 or 03 degrees. Once I know angle A and angle B, then angle C is just subtraction from 180. So if I do 180 minus 110 minus 27.03, we get 42.97 for angle C. And of course B is 20.68 centimeters. Alright. Again, it only asks me to find B, but again, if you had to find A or C, that's how you find A or C. And I could just easily found C in this step, and then once we see I could have found A. It doesn't matter which one you find. Again, as long as the acute, you're finding an acute angle every time. So if there's an obtuse triangle, there's one obtuse angle, the other two are acute. So if you have to use the law of sines, start being more picky about what you solve for. If you've already found, if you're up to 4 pieces of information, you know 3 sides and an angle, law of sines, find an acute angle. That'll be more trustworthy, I guess, to find the correct information.